We're going to look at collisions of carts and compare them under different conditions. And we've got a plunger that is triggered, so an explosive separation, carts when they collide separating after contact and then combining after contact, and looking at them colliding at different speeds and with one mass having double the mass of the other during these. Be careful that the carts and masses don't leave the track or fall on your feet. And we've got materials, carts, one with the plunger that can be triggered and one with a magnet on one end and Velcro on the other, so you can switch ends as you collide them. Useful to have a ruler along the length of the track as well. Here's just a repeat description of the tracks. And this is what you're going to do. First, make sure the track is level. If you gently push the cart on the track and it stops and doesn't roll forward or backwards, then it's level, but you might have to add wedges to make it level. And practice pushing the carts, one going faster, practice securing the mass to the cart. Don't just leave it loose on the top, and practice triggering the plunger without affecting the cart yourself as you trigger it. And then describe what happens in terms, what happens to the speed of each cart after the collision, and explain why. So the three different areas that we're going to look at. So the carts are separated by an explosive plunger, and trigger it, repeat with the plunger cart having double mass, put the weight on it, and repeat with the cart without the plunger having the double weight on it. Then another investigation with the carts, which will separate after collision. So the magnets with the same polarity are going to collide and have them colliding with the same speed. Repeat with one cart moving a bit faster. Repeat with one cart having the double mass, and you can do it with double mass and faster. The third scenario is where they combine after collision, and that's with the Velcro ends colliding. Start off with them colliding with the same speed, then repeat with one of the colliding carts moving faster, and then one of the carts having double the mass and colliding with the same speed, and then double the mass but moving faster. And you're going to see a video of the activities, which may help your description of it and explaining of what is happening in each case. So compare the result of the force in terms of each cart. Does it slow down? Does it speed up? Does it remain the same? And then is there a change in momentum? That's going to be your looking at impulse.
Okay. Well, yeah, but you pushed it. Yeah, I did. Okay, good enough. It works. Oh, I've just spilled everything. It's fine. Yeah.
So the one pushing or the one being pushed?
One being pushed.
Okay.
Or either way.
Either way, it doesn't matter.
Doesn't matter. Yeah, put on that one. Actually, no, put on this one. So then we can have like the test question, you know, where Big Bobby pushes it.
Oh yeah.
Yeah, we have to see what happens. Why not the middle one?
Just slide it in.
Don't you loosen it?
Is it? Yes, you have to twist it a little bit.
Oh, maybe.
Martin.
Not too tight.
Oh, sorry.
No, it's good.
Okay,
What do you
ready?
think is going to happen?
This one's gonna go fast. This one's gonna faster. This one's gonna go slower, but still move this way. I get this wrong. Yeah.
Very good job. Pretty good inference.
Just think about it. And your mass.
Yeah. So this has 2 times the mass.
So this is x. That's 2x.
No. Let's do Subat.
They're gonna move at a constant speed.
Oh, the constant speed. So acceleration is 0.
So if you say this one moves twice as fast.
Yeah.
But they're the same
In the
force applied
same
to each
amount of
other.
time. If it's twice as fast
Yeah.
in the same amount
At
of
the
time,
time,
how far should it go?
twice as far.
Twice as far. So how could you do that using this track?
Oh, we could put it like here at 30.
So if it's at 30, how far would that one go?
It would go 30.
And how far would that one go?
All the way to the end.
But that doesn't work.
Yeah, that's 3
40
times.
and 80.
Yeah.
Try.
40 and 80. Oh, yeah. Okay, so let's put this one. This, you know. Yeah, but it was gonna keep going.
Ooh,
And
hey.
this one goes. Oh, what if they switch? So like this one is going really fast. Like this
Yeah,
one, say
yeah,
this one's
that's
going
what
like 20 miles per hour, but that one's going like 10. And this one hits this one. Now this one's going 20. This is going 10. Yeah.
Alright, do that one more time.
3, 2, 1, go.
Yeah. Alright.
Slow. Sorry.
And does it work?
Yours still went so much faster.
Yeah.
Alright, 3, 2, 1, go.
Oh.
It's stalled. Okay, wait. Let's see if that was just like a
more
one
mass,
time. Let's
slower
just
velocity. So as a
let's just see if this is like. Here you go. Yeah, it stalls. Why does it stall?
because it doesn't have enough. It's so heavy that it doesn't have enough.
Velocity. No, so mass is so much. Velocity is so
I think if that one hits that one.
little. Stop.
Yeah, move that one.
Go. Why does it stop? This one.
Like
when you
when
go
you
at the
move them
same
at
speed,
velocity.
this one.
That.
The other first one.
I'm good today.
Yeah. And much different. So that one slows down a little bit. This one slows down a lot. And what if they're both moving? What do you think is going to happen?
I think the one that's moving faster is
No, I think
No,
the heavier one's gonna push.
the one with more force is gonna.
They're going
Wait
at
a
the same
second.
speed.
More force? Which one's going to
Sorry,
feel
more
more force?
inertia. Alright.
Which one is going to feel more force?
That one.
Well, we're both gonna feel the same amount of
Oh, yeah.
force. Alright, I will do slow here. Oh,
Same speed?
Oh,
Okay. Let's see what happens. What if the little one's going fast and the big one's going slow? The more massive one's going slow.
Then it's gonna go in that direction.
That one.
No, is it no? Is it no? Let's put this one still. See, it's not saying that one stops.
It transfers.
No, it doesn't. That one would stop. No,
No, still.
forward. And it goes forward. It doesn't even go backwards. Wait, hold up.
Yeah, because it has a greater mass.
Because it has greater mass.
So the momentum.
Boom.
Fine.
Boring. Ready.
Oh, they connect.
But that one's going
okay.
faster, so
Yeah.
yeah.
Chopstick.
Alright, now this one's gonna go faster. Go slower. Go.
Oh, if you're
Goes that way.
those.
Okay, what if this one has more mass? Just a quick little. I tried to put it in, like here, and then I thought I put it in, but it wasn't in. And then I didn't know why it wasn't.
It was funny actually.
She always wants smoke.
Like,
Okay, ready? 3, 2, 1. Yeah, we go that way.
the one with the greater.
How about
Wait,
do
was
that
that same
one?
speed?
How about
Do
that? No, how about that velocity? This is
The
still.
calculations were better. And then explaining.
Okay. So it's not math, it's just velocity.
Okay, now same speed, same speed.
Well,
Same as last time.
Okay, that makes sense. And now that one faster, this one slower.
when. Okay, so for 2B though. Okay, well, this one is going faster, this one is going slower, but because
This one
it
has
has a
more
greater
math.
mass.
And then, just as a repeat, you can pause this because it just describes the procedure in narrative form. And there are our cards. And very many thanks to WIS Team Science and Mr. Jollymore and his grade 9 Physics 1 class. Much appreciated.